All right, so welcome back. I'm going to just erase some of my old notes here real quick. So let's look at this transformation here. We know that a log is going to look like that, right? That's the basic. But if we look here, this x minus 2, remember, we've done these before. If it's inside the parentheses with the x, we have to do the opposite. So instead of going left 2, that's actually going to translate this right 2, okay? Right 2, we would have the asymptote at 2 going through the point 3, 0. All right, right here, that plus 3 is going to just slide it to the left 3. This negative is going to reflect it over the x-axis. It's going to reflect it down. This one, number 16, if it's a negative sign with the x, it's going to reflect it over the y-axis, going to flip it back and forth. So let's see what that one's going to look like. The normal base log function is going to look like that through the point 0, 1. But since it's negative, I'm going to put the new one on red. Instead of 0, 1, it's going to be 1, 0. And it's going to be looking like that. All right, so that red one is what that graph is going to look like. All right, when we go exponential, it's going to be the exact same. This one in red right here, that's our parent function. But since it's a negative, it's going to flip over the y-axis. And our new graph is going to be the one in blue. Right here, number 18, notice that it's an x minus 2. Remember, if it's x, it's sliding left and right, and it's the opposite. So instead of minus 2, it's going to go plus 2. So the blue here is our parent function, and the red, after we scoot it 2 to the right, is what it would look like. All right, so we've got a bunch of different transformation rules, but they're ones that you have seen before. All right, now let's talk about the domains of these. All right, now you've seen that we can't take the log of any. If we're going to take a log, it has to be greater than 0. So if I want to find the domain of this one's not going to be too bad. All I need to do is say x minus 2, whatever that is, has to be greater than 0, and then solve it. Add the 2 over. So the domain of this is x is greater than, not 0, x is greater than 2. All right, same thing for natural logs. All we have to do is say that x plus 4 has to be greater than 0. So subtract the 4. We're going to be x is greater than negative 4. Number 27. Now, here's the awesome thing about the domain of exponential functions. We know what those parent graphs look like, right? And this parent graph is going back to the left forever, and it's going to the right forever. So if it goes both ways forever, the domain is all real numbers. All right, so here's how we would write that. The left side of our domain is negative infinity, and the right side of our domain is positive infinity. So anytime we have an exponential like 27, 28, 31, 32, all going to have the exact same answers. So let's come back here with the logs and the natural logs. Remember, we're just taking whatever's inside the parentheses and saying that has to be greater than 0. Negative x has to be greater than 0. So divide by negative 1. Remember, when we multiply or divide by a negative number, we have to flip the inequality. So divide by negative 1. X is less than 0. Over here, nice little two-step equation. 3x plus 8 is greater than 0. Subtract the 8, divide by 3. You've got the idea. You know what it is. All right. So the rest of these, you're just going to have to list out the transformations. We've worked with these before. We've done them a lot. So hopefully you're doing well. Good luck with this.